The next section will be a pre-demonstration briefing from Grant regarding the correlation among the hybrid mass test suite, and then follow with the demonstration in the lab.
There's very little presentation up here because we're going to be going down to the lab in a minute. The first thing we're going to do, in fact, I have slide 59 of your presentation. Only because the time domain files from one of these specimens, the circular specimens, that specimen we actually recorded the data in time as a time file, and decimated it, or took every 30-second sample. So we were effectively sped up the test. Now that was a test that was 4.5 hours long, and by speeding it up we come down to about 9 minutes worth of. So we've got this situation, if you can visualise times, that the original earthquake was about 10 seconds, 9 seconds plus a tapering off time, and they repeated that 3 times at 3 different levels. So that was 30 seconds worth of earthquakes, 3 earthquakes in a row. That kind of 30 seconds or half a minute, it then became 4.5 hours of testing. So we've then sped that up by a factor of 32. So we're coming back in time, but we're still about 18 times slower than the real earthquake. And so we're just going to play that waveform that was seen just for the circular specimen, but we're going to play it over and over again. And we're going to play about 2.5 minutes of it. So when you see it, it'll happen, it'll go through 4 times. But we've tried to synchronise some of our correlated solutions kind of processing of our kind of strain or surface strain measurements. That's been a fairly exciting facility we've got. We're trying to improve that. There's some other kind of software we're looking at present, but also looking at ways of trying to automate that back into our systems. This particular one took a fair amount of post-processing, which thanks to Kevin, but we've got the files on all 3 different specimens there. So, and it's really good to visualise these areas, what's going on. Now for the next couple of minutes, I'm actually going to hook on to the controller from here. I'll see what I can do. Kevin, if you can come up for a second and explain what's going on. Okay, well, there's 2 reasons why I've got this. It's fairly hard to be all crowded around the screen over in the lab, so seeing a little bit of what's on up here is useful. Even though we're using Test Suite a lot, we still keep all the 793 on one screen. On the left-hand side screen here, we have the standard 793. We've got the degree of freedom software installed, which allows us to have 6 degrees of freedom with 8 actuators, with no hitches, and the fact that we can go into force control or force or moment control or angle or displacement control in any combination we like. So we've really got nearly 64 possible combinations that exist. And we're quite happy with the master actually going into all axes in force and moment control to 0 everything. We're actually feel comfortable in doing that. It's usually a little bit scary the first few times we've done it, but we can. And we do a lot of tests where we are kind of doing mixtures of hybrid tests, and in fact partial hybrid, where we might only have the X and Y axis coming out of the hybrid model, but we can then keep everything else constant, either at 0 angle, 0 moment, or some fixed force. So we've got the ability with our test suite software to actually decide what mixture we want, and we don't have to kind of reprogram the interface to suit any of the strange combinations. So we can cope with all combinations without having to reprogram things. It's been in this screen, we can choose for each of the 6 degrees of freedom. We can choose that force is 0 or moment is 0, or we can choose go remote to the hybrid interface. And the fact that we've got this ability, we've got 6 different options for each of the 6 degrees of freedom. The fact that the test suite program enables us to configure it at the time. But the beauty about this is that we've got limits set within test suite. If anything goes wrong, we freeze at all degrees of freedom in displacement control. So when you're starting to get spectacular displacements and everything starts to collapse on you, we can hit the limits, freeze it in displacement control. And so we stay within displacement control. In fact, we've been able to interrupt a hybrid test and then resume it within the minute without affecting it. So this hybrid interface that we have, or we've made out of test suite, from what we understand is rather unique in the way we're doing it. A lot of the other systems in the world use a dedicated software where everything's compiled and you can't change it. We can change everything at present in here, which is a bit scary, but so that's why we've got a number of fixed templates that we only do minor adjustments to make life easier. So I wanted you to see that screen. The fact that on the other screen we are always looking at the 6 forces, the 6 displacements of what we're controlling, but we're also looking at the 8 actuator forces and the 8 actuator displacements at all times. And the fact that we can put limits on the raw positions of actuators, limits on what's coming from hybrid land, because we don't trust what people do in MATLAB and in FE models. They're so used to crashing things and then rerunning the model. Here we don't let them do that. It's a bit scary. So that's why we've created this interface to make it student-proof and researcher-proof. Okay, now so when we're running this test, we'll be actually setting this up where I'll be actually receiving commands across the fibre optic link. We'll be using shared memory, but we're cheating. We're actually recorded data. It's actually pushed back through the Simulink and back through the system. So we are using our hybrid interface, but it's also told us one thing, that we can actually record some very complicated waveforms, anything that can be mathematically generated, well beyond the capability of what's in the test suite we can now do. We just do it in MATLAB. Okay, so that's all I wanted to do, to give you an idea of what I'll be seeing on the screens, because you all can't crowd around next to me. If we go down, some of the staff and other students will know where to go. Just lead the group down. In about 5 minutes' time, we'll start moving things. Okay.
Slab, heavily reinforced concrete, 1 meter thick, and the reaction walls there, also 1 meter thick, heavily reinforced concrete. This was designed to allow minimal deformations under the extreme loads that we apply on our tested specimens, on our structures. This one, MTS, it's a 1,000 kilonewton rated for tension and compression. In addition to that, we have got a series, a number of universal testing machines of lower capacity, 250 kilonewton, like that MTS over there. We use these machines mostly for fatigue testing, when we require a lot of cycles on certain samples, certain specimens. So we use them a lot for fatigue testing. We also have here a very high-speed testing machine that the piston of which can go up to 25 meters per second. And this is for high strain rate testing. In addition to what you see in this laboratory, we have got another laboratory at our Croydon campus. We cannot house all the facilities here because of the fact that this is a very expensive real estate, and it was very difficult for us to get this lot from the university on Burwood Road. So we have got in Croydon furnaces, high temperature furnaces that can simulate the standard fire curve. in time and also in temperature. So sometimes we bring these machines here, these furnaces here to do testing with load and fire simulation. So the one that we use for testing columns under fire is a furnace 3 meters high, and it can house a column up to 400 millimeter round or square. And some of the things that, of our future testing that we will going to do hybrid simulation with is to bring that furnace and put it underneath that hybrid simulation, the 6 degree of freedom system, because that furnace is actually made of 2 parts, and they cannot build it like that. So it's very easy to bring it and have it surround a specimen there, or even under this machine here, a single degree of freedom system. We also have got a furnace for bending test for beams, very large scale. Right across the room from here, that's, I alluded this morning to, that we are building a 3D printing facility for concrete. So that's being done over there. By the end of this year, that should be fully operational. And please drop by, have a visit, and look at the new facility. So back to Graham and Kevin. We have plotted this grid so that you can see the deformations clearly, especially the torsion and shear deformations or the axial deformation in the specimen. Graham.
Okay, so at present we've got the correlated solutions display up on the big screen. You can see, and you can actually see the 3 degree movements. I'll put it back now to Kevin to talk about that.
Yeah, this video demonstrates it's actually synced up perfectly with what's happening with that structure now. So all the movements that happened on the concrete field circular specimens, these are exactly those same movements. This test has been sped up by 32 times compared to the original tests that we did, but nonetheless it does show the capabilities of this machine. We couldn't test this fast properly, as that top crosshead there is 130 kilonewtons, 13 ton mass, which generates a lot of inertia, especially there. Now up on the screen as well, I don't know if your eyes and sensing, but up on the screen as well, we also have a good linear correlation of the sensing that is actually tested. That is also been synchronized in time. You can see a graph up there as well, X displacement versus Y displacement versus Z displacement. Up on the screen as well, also the camera is being mounted directly underneath that specimen there. So you can actually get sort of a bird's eye view, but an ant's eye view of our specimen. So you really see the movements that we're getting. With the digital correlation, we've actually been vectors painted on, which show the direction of displacement and magnitude of displacement when it plays the curve. And the graphs are also colour coded, so you can actually see in that case there we're plotting X displacement on that colour chart. The test will repeat again now, and we'll just show a couple of different graphs, but that is the gist of what we're looking at.
Okay, so as I said, it was only a 2-minute sequence and we just repeated it over and over again. We were hoping to try all 3 of the specimens, but then they all look fairly similar, so they'll come back to the one. But the key thing is that the fact that you can get all of that strain information in 3 dimensions. And so it's a fair amount of out of the whole area. And on some of the concrete specimens, rather than the steel coated one, you can actually see the zones where the cracks are starting to roll forward. This will guide. actually can actually see through the carbon fibre and the cracks behind it. Okay, at present you can see the double curvature. It's going plus or minus 200 millimetres. Believe it or not, I can actually go plus or minus 10 millimetres at almost 1 hertz. So throwing 13 tonne around with that kind of speed is quite interesting. Anyway, so this is kind of thing. I've deliberately moved it on this axis so you can actually see what goes effect. But it shows just how confident we are with this machine at present. We've just got used to it, and it's taken a while to take.
Up on screen again is actually what Grant can see right now. As you can see, it's got a plus or minus 200 millimetre stroke there. This is our rotation about Y.
For the control people, the command and feedback are right on top of each other. It's not just the command waveform, it's the feedback as well. Most civil engineering structures are well under 10.